Good morning, everyone. Hi, join fast. Today we'll be starting sampling distribution. Hi, morning. Today we'll be starting sampling distribution. Sampling. Good morning. Chalo. Let's start. Audible now? Yeah. Okay. See, sampling distribution means what? Basically, what is sampling? Sampling means you're basically doing a survey. Survey for what? Survey for small number of people. Survey for small number of people to represent the large number of people. Understand this. See here, I have to find out the average salary of 1 lakh citizens. But I can't go to 1 lakh citizens because that's not my means it will take a lot of time. So I take the sample of let's say 2000 citizens, somewhere from here, somewhere from there, all areas. And then I find that, see, from my survey, I've found out like this, and this I can apply it to the population. So basically, that is the whole logic. So sampling is a process used in statistical analysis in which a predetermined number of observations are taken from the large population. Predetermined. First, only I know that out of 1 lakh citizens, I'll be taking, let's say, 5,000 citizens as samples. So that is decided first. Hi, morning, morning. So that is decided first only. Predetermined number of observations are taken from the larger population. The methodology used to sample from a larger population depends on the type of analysis being performed. What do you mean by this? Now, these are all big words. Methodology, type of analysis means many of us get confused over here. What is this? See here, it depends on how much accuracy you want. Means, for example, suppose if you want more accurate results, so you'll follow a very rigorous method. If you want less accurate results, you can follow some easy method, isn't it? Suppose if I am doing a sampling of 1 lakh, population is 1 lakh. Population means total number of citizens, 1 lakh. If I want accurate results, then I'll give you two options now. Should I take the sample size as 20,000 or should I take the sample size as 2,000? I want more accurate results. So should I take the sample size as 20,000 or should I take the sample size as 2,000? I want more accurate results. Yes? What do you say? Should I take the sample size as 20,000 or should I take the sample size as 2,000? I want more accurate results. Yes, 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 everyone. Correct. I'll be taking 20,000 samples. Very good. So, the more samples I take, the more is the accuracy, isn't it? So, that this is called as methodology. What do you follow? Similarly, I can take other methods also. If I want more accurate results, I'll take more different methods. Okay? So, logic is that. So, now, so the methodology used to sample from larger population depends on type of analysis being performed. We saw one word over here that is called a census. Means 1 lakh population is there. I do the survey of all 1 lakh population. I go to each and every house and ask them whatever I want. So that is called a census. So that will be more accurate. And survey means I'll do the survey of let's say 5,000 citizens, isn't it? So that is the difference, census and survey. Okay. Uh, Suppose if you want to, let's take sampling simple example. You want to know whether the tea which you are drinking or coffee which you are drinking, complete cup of coffee, that cup of coffee is hot or no. Suppose let's say one. Second, is it sweet or no? So do you have to drink the whole cup? No. What do you have to do? You can take just a sip of coffee or sip of tea, and from there you understand, isn't it? That the whole cup is having sweetness, or whole cup is hot, or whole cup is cold, isn't it? So that is sampling. You need not drink the whole cup of tea to know what are the qualities of the tea or coffee. Got it? So this is the way it is done. See, simple. This is 1 lakh population. I can go to each house and ask them the details, but that will take a lot of time. Or else I can do some samples. So that will save my time and give me almost accurate results. Almost I'm saying, not exact. Some difference will be there. Almost accurate results. Okay? See what are the elements? Population and sample. Whenever you do the survey of entire population, it's called a census. Whenever you do the survey of small sample, it's called a survey. Okay. Definition, collection of all items means complete. All the elements are included in this in population. Whereas in sample, part of the population is taken, isn't it? Characteristics of population are called as parameter, but characteristic of sample are called as statistic. Kindly note this, parameter and statistic. What is the difference between them? See, parameter is same. Suppose if I find mean, let's say I find the mean of population, mean of population, it is called as parameter. Suppose if I find median of population, it is called as parameter. If I find mode of population, it is called as parameter. But now I find the same thing, mean, mode, median of sample. It is called a statistic. So when I do the same thing for sample, it is called a statistic. When I do the same thing for population, it's called as parameter. So action is same, only to whom you are doing, population and sample. Okay. So parameter and statistic. Got this point? Look at this. Size of population is always given as capital N. Size of sample is always given as small n. Mean of population is always given as mu. This is called as mu. Look at this. U and then one line. Mean of sample is given as x bar. X bar. Standard deviation is same. Standard deviation, standard deviation. Okay. But now what we do when we find out something for sample, we add one more point to this. That is called a standard error. This is not added in population. Standard error is added in sample only. So standard error, that is called a psi dash. Okay. So that is known as your standard error. Okay. So now suppose, let's say I'll ask, screen is not visible. Any problem? Yeah, started. Just log out and log in. Okay, just log out and log in. If the screen is not visible, kindly log out and log in. Okay, now visible. Okay, so now next one. Chalo, move on. Now visible, everyone. Anyone else is facing the problem? Anyone else facing the problem? Screen not visible. Is it okay? All of you, is the screen okay? Piyush, Sai, Lavanya, Reshma, is the screen okay now? Okay, one sec. Now okay? Chalo, let's move on. So now, let's move on. Bias sample. Okay? Biased sample. Suppose the parliament is debating on women's bill. You are asked to conduct an opinion survey. Now you tell me, serious, what is bias sample? Suppose if parliament is debating the women's bill and all are women over there. Let's say all of them are women. Then will you get the right answer in the debate? Will you get the right answer? All are women. So you won't get the right answer because that will be called as a bias sample. Because they'll definitely be in favor of that. Suppose if I ask you tomorrow, should there be, let's say, 7-day banking? Means all the days bank should work. What do you say? Should there be 7 days banking? So I'm asking to whom? I'm asking to bankers. So definitely the answer will be no, isn't it? Definitely the answer will be no. Correct? So this is called as bias sample. Suppose if I ask you tomorrow, should there be 4 days banking? Means 3 days holiday for banks. Then should there be 4 days banking? Again, this will be the bias sample. If I ask the bankers only, they'll be happy. They'll say, oh, very good, 4 days banking. Or should there be completely 5 days banking? Right? So that is called as bias sample. Bias means what? You take the sample from a particular region or a particular category. So they'll always answer you in their required format. So that's why if you want correct sampling, you have to take the sample from various sectors, various regions. Okay? Got it? Clear? Now, what are the various methods of sampling? One is probabilistic sampling or probability method, and second is no probability or judgmental. This is also, these two are same. This is also called as no rule. Purposive, no rule. Okay. So, what are the methods? Look at this. Probability sampling. There are basically four methods. What is probability sampling? What is probability sampling? Hi everyone, are you able? Am I audible? Everyone, am I audible? Now visible, no? Yeah. So now, in probability sampling, what is the meaning of probability sampling? See this, the probability sampling means each one will get equal chance. There is no partiality, there is no biasness. That is known as probability sampling. Each one has got equal chance, no biasness, nothing biased. So that is called as probability. Means what? Let's see four examples. From there you'll understand. Suppose if I close my eyes. Suppose if I close my eyes tight and I'm given, let's say, 100 students or 50 students. I've been told to find out, let's say, 10 students. I close my eyes or my eyes are tight, let's say, tight. I can't see anything. I have been told to find out 10 students from a group of 50 students. Now, what do? I close my eyes are tight, I can't see anything. So, I'll just move within those 50 students and select any 10. This, you. I'll move entirely into that 50 students gap or that cluster. So, what am I doing? Am I giving the equal chance to everyone? Am I giving the equal chance to everyone? What do you say? My eyes are tied. I'm moving among the students. I don't know anyone. And I'm selecting 10 students, any 10. So, am I giving the equal chance? How? Why no? Why no? Because I can't see them. So here I am giving the equal chance to the students. Why? Because I have closed my eyes and then I am moving among the 10 students. So do I have a partiality? Do I have somebody whom I know? I am selecting that because I don't know. My eyes are tied. So this is called as simple random sampling. Simple random sampling. In simple random sampling, what happens? I'll select any 10 students while moving into the group. So that is one way. So this is one of the best methods of sampling, simple random. This is actually the true sampling, simple random sampling. But what happens? We want some other methods, or we want some accurate results, some more accurate results. So what do we do now? All these 10 students, all these 50 students, okay, which are the 50 students over there, what will I tell them? See, again, I have closed my eyes, I have not opened my eyes. I tell these 50 students to stand in a line. I'll tell these 50 students to stand in a line. I won't tell them what am I going to do. I'll tell them to stand in a line. So they don't know whom I am selecting, how many I am selecting. Then I tell them every every fifth student will be selected. So again, 50 students, every fifth student, so I am selecting 10 students. So again, am I doing some partiality in this? Every fifth student, am I doing the partiality? I don't know anyone because I have again closed my eyes. I have told them just to you stand in a straight line. Am I doing some partiality over here? No. Why? Because I don't know anyone. I'm just telling them to stand in the straight line, and then telling them every fifth student come out. So this is known as systematic sampling. Systematic. Systematic means what? I'll tell them to stand in a straight line and then select every fifth, every tenth, whatever I want. Right? So this is also equal chance. I'm not doing any partiality over here. Third one, I'll tell the students what you do. Now, here again I'm closing my eyes. I don't know any student. I am closing my eyes. I don't know any student over here. I'm telling them now what you do. You all make groups. Groups of how? Let's make the groups of, let's say, 40 to 50% marks. You stand separate. 50 to 60% stand separate. 70 to 80, 80 to 90, 90 to 100. You stand separate. Okay? Right? So 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. So total 6 groups I have made. 6 groups. Again, I have closed my eyes. I have not told anyone. I don't see anyone. Now these students are standing in this 6 groups. Again, what I am doing? I am telling them, see, 6 groups are there. Now every group come any 3 students or any 2 students, whatever I want. So again, what am I doing? Am I doing a partiality? No, because I have no control over whom to select. I am following a rule. Whenever you are following a rule, that is called as probability sampling. Okay? So now what happens? Look at this. Stratified sampling. This is called as stratified. Strata means what? What is the word strata? Strata means steps. You know steps. Whenever we climb steps, those steps are called as strata. So I am creating steps 40 to 60, 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. So I am creating a divide among the students, but I am not doing any partiality. Okay. So this is called as stratified sampling. Whenever you divide them in percentage of marks, or let's say anything, you can divide them in percentage of height also, in percentage of weight also. Okay. So now what happens? Look at it. Those who are having the marks of 40 to 50%. Now you tell me, The one who is having the mark of 40 to 50%, will he or she think same as the one who is having the marks 90 to 100%? The one who is having the marks 40 to 50%, will he or she think the same way as 90 to 100% mark student? What do you say? Will they think in a similar fashion? 40 to 60 versus 90 to 100. What do you say? Will they think in the same fashion or same way? Yes. Will they think in the same way? 40 to 60%, 40 to 50% versus 90 to 100%, right? They will not think in the same way. 40 to 60 will think of passing, whereas 90 to 100 will think of scoring. So their thinking methodology will be different. So this is the main beauty of stratified sampling. What is it? The students in the same group, or we call it strata, within the same strata have similar qualities. Means what? All 40 to 50% students will first think of passing. All 90 to 100 students will first think of scoring. So similar qualities. And different strata is having different, they have different qualities. Okay, so that is called as stratified. Okay, got it everyone? Clear? Shall I move on? Now cluster. What is cluster sampling? Cluster is generally done as per the region. As per the region. Okay? Means Goa. What I would say is, see, all the students are there. What you do, some of you who are from Goa stand this side. MP stand this side. UP stand that side. Tamil Nadu stand that side. What am I doing? I am doing the geographical divide. But again, am I doing a partiality? No. I am following a rule. Anywhere where a rule is followed, that is called as probability sampling. So cluster will be related to region. Now look at it. If I think of Goa, will there be a topper among them in Goa? Means will there be a student who has scored more than 90? Will there be a student who has scored 40 to 50 in Goa? Yes, what do you say? Will there be a student who has scored more than 90% in Goa? Means can there be? Will there be means we don't know. Can there be a student who has scored more than 90% in Goa? Yes or no? There can be, isn't it? There can be. Similarly, now look at it. Pay attention. Can there be a student who has scored more than 90% in MP? There can be. Can there be a student who has scored more than 90% in UP? Yes. Can there be a student more than 90% in Tamil Nadu? Yes. In Kerala, can there be a student? Yes. So what does it mean? What are we doing? What are we saying over here? It means every region, Goa, Tamil Nadu, UP, MP, Maharashtra, Rajasthan, Delhi, every region will have some students which are above 90. Similarly, every region will have some students which are less than 50, 40 to 50 also. So what does it mean? It means that Within Goa only, look at it. Within Goa, there is so much variety. One student is of 40%, other student is of 90%, other student is of 60%, somebody might be of 70%. So you are having a huge variety. And same variety exists in UP also, in Tamil Nadu also, in Kerala also, in Rajasthan also, in Delhi also. So same difference exists. 40, 60, 70, 80, 90, all the students are there. So within the same cluster, there is a huge variety. Same cluster, huge variety. And within Goa, MP, UP, this Rajasthan, Tamil Nadu, Kerala, there will be students of all categories. So within different clusters, they may have similar qualities. Goa also has topper student. Tamil Nadu also has topper student. Rajasthan also has. Delhi also has. Right? Somebody from Northeast, Sikkim, Nagaland, they can also have. Right? So kindly remember in cluster sampling, within the same cluster, there is a huge variety. And within different clusters, there may be similarities. So now look at it, stratified and cluster. Understand the difference. They are exactly opposite of each other. Stratified and cluster, they are exactly opposite of each other. See this, within the same strata, similar qualities. Within the same cluster, different qualities, huge variety. Within different strata, different qualities. Different cluster, similar qualities. So these two are opposite of each other. Opposite. Okay? But all are probability sampling. Why? Because in all of them, we are following a rule. Any rule when you follow without biasness, it's called as probability sampling. Out of these four, two will be asked in the exam. Definitely. Simple random, systematic, stratified, and cluster. Two are definitely asked. Mostly out of these two, they ask one question on these two combined and they ask systematic separate. Okay? So this is known as probability sampling. See this, simple random. So select samples by methods that allow each possible sample to have an equal probability of being picked and each item in the entire population to be included in the sample, isn't it? So anyone can be picked. I'll go here, anyone, anywhere I'll go and select. So that is called as simple random sampling, right? Look at this simple example. A, B, C, D, four students I'm having. So what are the ways in which I can have this group of two? So out of four, I have to select group of two. How many groups can be formed? I can form AB, AC, AD, BC, BD, CD. So this you can judge how many groups you can form. That is called as NCR. N is total number of students. R is a group. How many you want? So it is called as 4C2. You will be having this in probability. 4C2. So it is 4 factorial n factorial upon r factorial into n minus r factorial. N factorial upon r factorial into n minus r factorial. So you will get the answer as 6 groups. See, 6 groups are formed. Suppose if I want to find out the drawing these samples of two people. Suppose if I want, let's say, the probability of finding, let's say, group AB, single group AB, among the 6 groups. Suppose if I want to find the probability of AB among the 6 groups. So what is the probability? Say this. AB is only 1 and total are 6. So you'll be having 1 upon 6. 1 upon 6. Similarly, if I want BC, 1 upon 6. CD, 1 upon 6. Okay? So probability of finding a group is 1 upon 6. But now I ask the same question. What is the probability of finding A among these six groups? What is the probability of finding A among these six groups? Now I want only A. Now where is A possible? See this. A is possible in AB also, AC also, AD also. So how many ways? Three. So 3 is a success upon total. What is the total? Total is 6. So 3 upon 6. So 1 upon 2. Similarly, I'll say if I want B, again see this, B here, B here, B here. So it is 3 upon 6. Similarly C, similarly D. Got it? So probability, you'll have a separate chapter. How to find out is success upon sample space. Okay? Now without replacement and with replacement. Suppose if I write PQRS on 4 identical slips, means what? I'll take any 4 letters PQRS. I'll write it on 4 chits and I'll throw the chits in the air. Okay? Then I select one. One chit I'll select. And that chit when I select, I'll see the what is written on it, PQRS. And then I'll keep it separately. I'll keep it separately. So now how many chits are remaining? 3, isn't it? Earlier there were 4. Now I've selected one and kept it separate. So now how many are remaining? 3. So now I have to select among these 3. Again I'll pick up one chit. So what is happening? Now I am selecting from the remaining 3. Isn't it? Now what will happen? I'll take that one chit now and keep it separate again. Now how many are remaining? 2. So whoever I have to select within the remaining 2. So such sampling where we don't replace it, we don't put it back, is called as without replacement. Is called as without replacement. Okay? Where we don't put it back. That's called as without replacement. Got it? So this type of sampling where we don't put it back is called as without replacement. Now same experiment, again do it. But what you do? You take this chit, see it, PQRS, what is written. Again put it back. So earlier I had selected from 4 samples. Now I saw that chit and again put it back. So how many I am having now? Again. Now you tell me. I have again put it back. So how many samples I am having now? Yes? I had 4 samples earlier. I saw one chit and I put it back. Same 4. Again I do the same experiment. See it, again put it back. So what is happening over here? This will never end. This will never end. This is called as sampling with replacement. Okay? So without replacement, with replacement. One of them is asked in exam. Without and with. Whenever you separate it, you don't put it back. That is called as without replacement. Okay? Without replacement. Do you know the best example of without replacement? What happens? Sampling without replacement. Have you seen this? I'll tell you. Simple example I'll give you. Those students who are clearing their top grade exams like IIT or IIM, Indian Institute of Management. And after clearing their IIT and IIM, they go and settle in USA. They go and settle in USA. So this is called as without replacement. So what is happening? Look at it. The clever students who are there, They are not getting replaced. They are not coming back. So that is without replacement, right? But the same student from IIT or IIM, if he stays within our country, so that will be with replacement. So our brain drain won't happen. And this is the best example of without replacement and with replacement, isn't it? In your bank also, in your branch, suppose there are 5 employees in your branch, and then the head office says, what do you do? Or regional office says, what do you do? One employee you go to other branch. Out of 5, one is gone to other branch. So what happens in this case? One is gone to other branch. Now replacement has not come. So you will be faced with four employees. So this is called as without replacement. But if the regional office says, you go from here and I'll give you someone else. So that is with replacement, right? So the best examples are these, with and without replacement, okay? We use the term infinite population when we are talking about a population that could be enumerated in a reasonable period of time. What do you mean by this? Infinite population. Many of us think that infinite population means which we cannot count. Pay attention, huh? Many of us think infinite population means which we cannot count. Suppose if I tell you that count 1 lakh, this means there are some, let's say 1 lakh students roughly. Count them 1, 2, 3, 4, 5, 6, 7, 8. Count them. So is it infinite population or finite population? 1 lakh students I am telling to count. Go and count. 1, 2, 3, 4, 5, 6. Is it finite or infinite? Finite means which can be counted. So is it finite or infinite? Roughly there are 1 lakh, right? So these are finite students. Finite means it can be counted. They can be counted. Now, when will they become infinite? See this simple example I'll give you. I'll tell you to count this 1 lakh students roughly. I don't know exactly 1 lakh are there or not, but roughly 1 lakh. Count these 1 lakh students in next 2 minutes. Go and count these 1 lakh students in next 2 minutes. Count fast. Chalo. Roughly 1 lakh students in 2 minutes. Is it possible to count 2 minutes? Same 1 lakh students in 2 minutes. Is it possible? No. For you. For human being, it's not possible. Right? Now I'll tell you the same 1 lakh students, count them in 1 month. I'm telling you, count the same 1 lakh students in 1 month. So now is it possible? Counting 1 lakh students in 1 month. Is it possible now? Counting 1 lakh students in 1 month. Is it possible? What do I say? Counting 1 lakh students in 1 month. Is it possible? So it is. Or let's say 1 year. If I give you 1 year, count 1 lakh students in 1 year. Is it possible? Yes, it is possible. You can count them. In 1 year, it's what's the difficulty? You can definitely count it. Even in 1 month, you can do it. So now understand the problem. Students are same, 1 lakh. But earlier I had given you 2 minutes. Now I am giving you 1 month. Now in 2 minutes they become infinite. But in 1 month they become finite. Getting the point? So what is infinite population? Which cannot be counted in a given reasonable time. 2 minutes. Given time I can count, so it's infinite. In 1 month I can count, so that is finite. Okay? So understand the difference between infinite and finite. Time is important. In how much time can you count? We use theoretical concept of infinite population as approximation of large finite population. Approximation of large finite population. Okay? So we use this theoretical concept as large finite means approximation, means when you can't count them, what will you do? You'll do some sample survey. Out of this 1 lakh, count some 2000 and ask them whatever you want. Right? So that's an approximation. Systematic sampling now. So got this point, infinite and finite population. Everything depends on time. Numbers are same. Okay. Now systematic sampling. In systematic sampling, just now I told you, I'll tell them to stand in a straight line. Elements are selected from a population at consistent level, that is measured in time, order or space. I'll tell them to stand in a line and then I'll tell them to select every fifth student. So that is systematic sampling. Okay? Systematic. Got this point? Systematic sampling differs from simple random sampling. What is the difference? This question is asked in exam. What is the difference between systematic and simple random? See here, each element has an equal chance in simple random. But in systematic, each element, each sample doesn't have a equal chance. Why? Why it doesn't have an equal chance? Because here, whenever I tell every fifth student, okay, so these four don't have a chance of getting selected. So in systematic sampling, every sample doesn't have an equal chance. But then also it is probability. Why? Because I'm following the rule. I'm not doing the partiality. I know this person. I'll tell them, you come out. I know this person. I'll tell him, you come out. So that I'm not doing. So whenever I'm following any rule and sticking to that rule, so that's called a systematic. So in systematic sampling, every sample does not have an equal chance. Whereas in random sampling, simple random, every sample has an equal chance. In systematic sampling, there is a probability of introducing an error in the sampling process. Error can be there. Why? Because four persons are not selected. These four, they are not selected. So there can be an error. The system chosen may cause a problem. How do I choose every fifth person? So that can be a problem. Got it? So remember, this question comes in exam. Systematic sampling, every sample does not have equal chance. Whereas in simple random, every sample has an equal chance. What are the advantages? This method may require less time and sometimes result in lower cost than simple random. So less time is required, lower cost. Okay? Got it? So now next is the stratified. This we'll do it next lecture. I think so this week you will be having a gap. I think so because now there are electives coming up. Electives coming up of this CIB June exam. So I'll be taking two electives. I do take two electives. One is risk management and second is the central banking. So both the times will be tied up, 6 to 8 in the morning and evening 8 to 10. So I think so Adda will be giving the gap for 1 week. So we'll be meeting in the next week. In the meantime, I'll share the PDFs for you on the WhatsApp group, on the, not WhatsApp, Telegram group. Okay? So study for 1 week. This week you'll be having a gap. Okay, everyone? Got it? Shall we leave? Okay. Chalo. I'm there on the Telegram group. Okay.